Hey, hi. So we're going to continue molar conversions. I don't know if I'm going to have all of you watch this or only some of you watch this. Doesn't matter. Let me go ahead and share my screen. And I'm just going to take it one little step further, okay? It's nothing crazy. I just want to explain something to you. And I call it taking elements into or taking elements out of compounds and putting elements into compounds and incorporating that idea in a math problem. All right, so we'll call this moles of elements and compounds. All right, that's what I'm going to call this, moles of elements and compounds. And this is what I want you to see, guys. If I see this as one molecule of water, right? Then I know that I have 2 atoms of hydrogen and 1 atom of oxygen, okay? Atoms are the representative particles of molecules. If I don't call this molecule, this water a molecule, but say that I have 1 mole of water, then I could say within that, I have 2 moles of hydrogen atoms, and I have 1 mole of oxygen atoms. All right. Okay. If it was to be an ionic compound, let's say I have 1 formula unit of aluminum carbonate, right? Oops, that would be a 3. All right, how could we break this down and really understand what particle is making up, how the smaller particles build larger particles? It helps students in their understanding of vocabulary, really noticed. So in one formula unit, one of the smallest pieces we had, we would have 2 aluminum ions, right? That would be Al3 plus. We would have 3 carbonate ions, right? So we would have charged particles in there, right? Within this, we would have 1 carbon atom and 3 oxygen atoms, right? Because that is a molecule that's sharing their electrons, so it's composed up of atoms. It doesn't have charged particles, right? Then we know that the atoms are made up of protons, neutrons, electrons, right? But we're not going to go there. Now, good. Or if I have 1 mole of aluminum carbonate, right? Then I have 2 moles of aluminum ions, and I have 3 moles of carbonate, 2 negative ions, okay? Now, I would like to, okay, never mind. Okay. Now, I do want to clarify something, that each of these contains the 1 carbon atom and the 3 oxygen atoms. But over here, right, I actually have 3 carbon atoms and 9 oxygen atoms, right? But this was in reference to only 1 of those molecular ions, if you will, okay? And I could not look at this in terms of formula units, but I could look at this in terms of moles. And then I would have moles of the ions and 3 moles of the ions, right? Once again, I would have a total of the 3 times the 3 would give me 9 moles of oxygen atoms and a total of 3 moles of carbon atoms. if you don't understand that, I don't want you to worry too much about it. Okay. How would we apply it real quickly? How many grams of, let's see, what would we, how many grams of oxygen in a sample, in a, let's say, 45.0 gram sample of carbon dioxide? Okay. So we're given 45 grams of carbon dioxide. All right, this is what we have. So that's what we'll start with. We need grams of oxygen. All right, so what we're going to do is we're going to go from grams to CO2 to moles of CO2 to moles of oxygen, and then we can go to grams of oxygen. All right, so let's look at our 45.0 grams of carbon dioxide. And if you want to go ahead and pause and then fast forward or something, see if you can figure it out yourself. This is 44.01 grams per 1 mole. I know that. That's moles of carbon dioxide, right? Moles of carbon dioxide will go here. Now, I know that every 1 mole, this is your new step. It's the only thing new. 1 mole of carbon dioxide has 2 moles of oxygen. Right now I'm talking about oxygen atoms, and every 1 mole of oxygen weighs 16.00 grams. Boom. All right. So that is grams of oxygen atoms. And that's what we would have needed. All right. Grams of the atoms. All right, we could do that real quick. Let's see. 45. So look here, guys. Notice these are going to almost cancel each other out. I have a number slightly greater than 1 times 2, which is something slightly greater than 2 times 16. So my answer should be a little bit greater than 2 times 16, which is 32. So I've got 45 times 2 times 16 equals, divided by 44.01 equals 33.0 if you round that appropriately. And that is grams of oxygen atoms. All right. Let's look at this slightly differently. Let's say that a sample of, a sample of calcium phosphide contains 9.83 times 10 to the 24th atoms. Oops, nope, that won't work. Ions of phosphorus, or phosphide ions would make sense. Phosphide ions would make sense, right? If you want to write that, that would read better, right? What is the mass of the sample? Okay, so let's look at this. We are given ions of phosphide, or phosphide ions, right? That's what we're given. So we know that's what we'll start with, all right? We need to know the mass of the sample. So we need to know the mass of the compounds, right? So this is what we need. And that calcium phosphide is Ca3P2, right? You know that. If you're watching this, you know that. Ca3P2. So we need to go from this number, what we're given. Remember, we always start with what we're given. And we need to end up with the mass of the compound, right? So let's write a roadmap. We can go from ions, phosphide, ions. And then we can put the ions, to moles of phosphide ions, to moles of the compound, to mass of the compound. So if you understand how to work a T-chart, you can get anywhere as long as it's a legit question. All right. So we've got 9.83 times 10 to the 24th phosphide ions. All right. Now you go ahead, come back. I know that I'm going to convert my ions to moles, right? Because they're 6.02 times 10 to the 23rd, and every 1 mole, that's moles of phosphide ions, mind you. There are 2 moles of phosphide ions for every 1 mole of calcium phosphide. And every 1 mole of calcium phosphide, right? Let's get the molar mass. That's going to be my grams of calcium phosphide. So I'm going to get my 3 calciums. That's 40.08 times 3 equals plus parentheses 2 times 30.97 close parentheses equals. And the molar mass of calcium phosphide is 182.18. Okay? Now, I'm just going to take that and multiply it by the other number on top. And I'm going to divide it, parentheses, Avogadro's number times 2. And I'm going to get and round to the appropriate number of significant figures, 1.49 times 10 to the 3rd. And that is grams of calcium phosphide. The only new step you have learned is to put the moles of the ion into the ionic compounds, or take it out, it could be reversed, or to put or to pull the moles out of the compound. Did I not make a step there? No, I didn't. Okay. All right. So you can pull the element in. You could put the element in, or you can pull the element out by using the subscripts. All right. It is a ratio as well. Let me know if you have further questions. I'll try to put some questions for you to answer together on that. Okay. Thank you. Appreciate you. You're doing a great job.